I see that some of you are already logging in to using your My VMware accounts. If you don't have a My VMware account, that's fine. We have a generic login that we're going to provide when we actually walk through this sizer. So just wanted to give you a heads up. We still have, I think, a couple of minutes before we kick things off. But again, walking around, I saw that some of you guys were already logging in. I just wanted to let you know that we have a login for you if you do not have a My VMware account. All right, so let's go ahead and get started. So quick introductions. My name is Anton April. I'm a vSAN SC based in Colorado. I cover enterprise accounts for VMware. So I cover about 4 different states. But again, based in Colorado, and I've been with VMware for about a year. Prior to joining VMware, I was part of a Dell EMC team for about 12 years. And today, we're going to be talking about the vSAN sizing tool. And I just want to go over the quick agenda here. So we're going to go through the vSAN sizing overview. You know, why use a sizer? I come from a world where, typically everybody has their own, homegrown calculators, Excel sheets that they're using to put together these HCI clusters and just, sizing traditional storage in general. Usually everybody has their own methodology, so we'll talk about some of the best practices and reasons why the sizing calculator that we've put together is a good thing to use for vSAN. And then we'll go through different assessment tools, right? So along with the sizing calculator, the assessment tools, and we'll go through the various type of assessment tools, kind of provide you with actual data that you can feed into the calculator versus doing kind of like sticking your finger in the air and trying to figure out what the actual requirements are going to be. You can actually point to data metrics, right, and use those to inform your design decisions. And then we'll go through an actual demo together that I'll walk through with you guys and show you how I use the vSAN sizing calculator and then address whatever questions you guys may have. Sounds like a plan? So, so the vSAN sizing tool. So when I came to VMware, we were actually using a different tool, and when we put together this vSAN sizing calculator, it for me was it was a godsend, right? There was all of these kind of hodgepodge Excel sheets that everyone was using to put together their own sort of calculations, and no one's methodology was the same, right? You go to 10 different engineers and you get 10 different type of vSAN cluster designs. And so the good thing about this calculator is that it gives you kind of a programmatic way to approach your vSAN designs, and it incorporates our vSAN design best practices, right? And we'll talk through what some of those best practices are, but it makes things a lot more simple and a lot more repeatable. So when you start talking about, sizing for vSAN or sizing for HCI compared to traditional storage, there's a lot to consider, right? When you're looking at traditional storage, usually what you have to worry about is performance and capacity, right? When you start talking about HCI, now the underlying infrastructure is not just, performant, or is not just dependent on the available capacity that you can provide and the amount of I/O and latency you can get from those storage arrays, but now you have to consider what the VM resources are going to require from a compute and memory standpoint, right? So there's a lot that goes into the calculation, and I just called out a couple of things here, right? So you have to look at the vCPU core to, the vCPU to logical core ratios, the vCPU to VM ratios. You have to understand your failure to tolerate methods. And when I say failure to tolerate, what I'm talking about is, in a 4-node cluster, for instance, where you have 4 physical servers, traditionally that would be back-ended by fiber channel or iSCSI storage. If you lost a node, that would be an HA event. From a compute resources standpoint, your environment would still be up and running because the underlying storage is still intact. Well, now, if you lose a node, you're losing some of that storage. So there's some forward thinking that has to go into your design principles to account for that potential loss of a host or of a component within that host, right, to ensure that you have data availability if you lost a node. And so just talking around vSAN sizing best practices, right? So there's a few different ways that you can deploy vSAN. The minimum amount of nodes we support is a 2-node cluster. Typically, the 2-node cluster is designed for the edge, right? So remote office, branch office. But typically, what we see in production are 4 nodes being deployed. And 4 nodes being deployed for the reason that I mentioned, right? So if you think about 4-node cluster where you have RAID 1 deployed, right? So you have a full copy of the data on one node, another full copy on another node, and then you have a witness component. And that witness component is there so that you can maintain quorum in the event of a loss. With the 4th node there, if you have a failure, now you have somewhere to rebuild that data to, right, and still maintain availability. In a 3-node design, you don't have that flexibility, right? So if you lose a host in a 3-node design and you suffer another failure, you're in a bad way, right? So that's often when you talk to the vSAN specialist, right, will recommend 4-node deployments, and that's the reason why. And I remarked on this earlier, but when you start talking about the different design or assessment tools, so I've been doing this for a long time, and I remember the days when we used to pull in IOStat and perfmon data. We try to get some information about the environment from understand the IO, understand the latency that's being driven from that workload, and try to feed that into our assumptions that we're making about the overall design. As of late, what we've actually pivoted towards is VMware has a partnership with Dell, and that partnership led to us using the VMware HCI assessment tool. So that's powered by Live Optics. Some of you may be familiar with that tool. That was formerly DPAT, pretty prevalent in the industry. But that's primarily what we use as a data analysis collection kit to understand what's going on in existing environments. There's also VROps. So if you guys are familiar with VROps, there's some great information that you can glean from that tool. You can actually understand workload placement, right? So if you're a vSAN environment, or you're looking at moving to vSAN and you're coming from traditional 3-tier storage, right? You can understand what the potential performance impact may be moving that VM over to vSAN. And then we have RV tools. So just a list of some of the assessment tools that you can use. And again, the point here is we want to try and be as scientific as possible. and understand what numbers are actually, driving some of the recommendations that we're going to have in terms of what kind of drives we're going to use, the number of hosts, how many failure domains do I want to have in my overall cluster, and so on. And so we'll get to the actual sizing tool, but one of the things I like to say is the sizing tool is great, right? But it's not the end-all be-all, right? So you also have to, I'd say, bring some practical consideration to, your design. And there's some things that the tool, though it's great, is not going to call out. And there's some particular workloads that can be a little tricky when it comes to sizing. VDI is a perfect example of that, right? You can understand, like, hey, I'm going to be leveraging link clones or full clones, and I'm going to do X, Y, and Z when it comes to the VDI environment. But I would really encourage, if you're sizing for VDI, that if you don't have a certain level of expertise in that domain, that you reach out to an expert while you're working through sizing for that type of workload. The other thing that the tool doesn't do is it won't size for 2-node clusters. It'll provide some good information into your overall config, right? So you can sort of glean what I would need from a capacity performance standpoint, and then put that into an actual 2-node host type cluster. But there isn't a drop down to say, hey, tell me what this looks like in a 2-node cluster in the tool. So just something to be aware of. And then always, that whole saying of just because you can do it doesn't mean you should. So there's some things that we can do in vSAN that sound good, but you wouldn't necessarily want to put that into practice, right? We support a 64-node cluster. I don't know if and I have some of my colleagues in the room with me. I don't know if anybody's ever actually seen that in a while, right? That's a pretty large failure domain. So I would say on average, I typically see about 8 to 16 node clusters, right? We've also recently on our HCL, we've certified a 30 terabyte SSD, pretty huge SSD, right? But when you start thinking about from a design perspective, do I go with 10 3.8 terabyte SSDs for your capacity tier, or would I go with a single, 30 terabyte drive? To me, the obvious answer is you would go with multiple 3.8 terabyte drives, right? It's, again, just like those practical considerations. Just because you can do it doesn't mean you should. That should go into to your design considerations. And then also, when you go through the tool, you'll see one of the things that we're beta testing right now is the ability to spit out a ready node config, right? So you can select the OEM manufacturer that you would like a server BOM for. So whether that be Dell, HP, Cisco, Supermicro, right? But just know that the ready node config, the BOM that it spits out, can be modified. And I've included a link to a KB article that talks through what things you can and cannot change when it comes to ready nodes, right? So you can modify core count, the clock speed on the CPU, increase the RAM. So just know that, once you get that output of a server config, that you can modify some of those things if you need to, right, in your design. All right, so we're going to go through. This is the live optics tool that I was talking about before. Again, this formerly was called DPAC, but now it's called live optics. So what we're going to do is we're going to take some data from the live optics tool, and we're going to insert that into the sizer, and we're going to walk through the sizing tool together. And so this is just to capture a snapshot of some of the information that you can get from the live optics tool. So you can see the peak I/O usage, right? It'll give you an idea of what the I/O profile looks like, so you can understand if this I/O workload is going to be more sequential or more random I/O. right? So in this scenario, we're looking at 56-44, basically 50-50, right? From a read-write ratio perspective. It'll also, you know, allow for you to see, like, how many writes am I sustaining on a daily basis? And these are all things that you should be thinking through when you're talking about your vSAN design. So let me go to the information that we're going to use for sizing. So this is the URL. It should already be pulled up on most of you guys' desktops there. But vSANsizer.vmware.com. And at the bottom of the screen here are login credentials that you can use if you don't have a My VMware account. You can log into so that we can walk through the sizer. And so I'll give you guys a couple of minutes to get logged in. And if anyone has any trouble logging in, just raise your hand and let us know. We'll help out. And then once everyone's logged in, I'm actually going to flip to the sizing tool, and we'll go through that together. Yeah, so at the bottom here, there's your username and password. So it looks like we're waiting on one. Is anyone else not logged in? You're having troubles? So Lexi, I think back here, there's one. But what we'll do is when we're going through the sizer, we'll talk through all of these different data points and what this means. And if there's any questions about any of the information that we're going through, please feel free to raise your hand and ask the question. All right, so I'm going to switch to sizer here. So you all should be at the first page of this workflow here, where it asks for the profile mode. So there's two options when you talk about vSAN configurations. There's all flash, right, where you have the caching tier, which is going to be made up of SSD, and the persistent or capacity tier, which is also SSD. And then the other option is what we call hybrid, where that capacity tier would be spinning disk. We see more and more customers deploying all flash, and it's just because of the economics. There's different types of SSDs available now, right, with TLC, MLC. The cost and being able to incorporate deduping compression really makes that the most logical option for most customers. And then deployment scale, this is data center scale. We're going to select, so we'll just click next here. And then we're going to select the workload. So there's 3 different workload types. There's VDI, database. If you select on database, you would see that there is SQL and Oracle, and then there's general purpose. We're going to select general purpose. And then here's where we're going to enter in. Here's where we're going to enter in this information. So put this back up on the screen, and just enter in the total number of guests. Basically, fill out all those inputs with the information up on the screen there. Sure. Sorry about that. And so really, I mean, it's really important to understand, how many, again, when we're talking about combining storage and compute, understanding the total workload, how many VMs do you want to support in the cluster? So that's your total VMs. And then understanding, and a lot of times, we run the DPAC information. You can actually see this in DPAC. You'll see what's the vCPU to core ratio in the customer's existing environment or in your existing environment. So all of the data points from a live optics standpoint that you're looking for and that you would fill out in the sizing tool are actually incorporated in the live optics tool. Is anyone still using the information up on the screen? Okay. Sure. Yeah, so I would just, so the average CPU per guest VM. Yeah, so I think the way that it breaks it down there is it's actually asking for the logical CPU, the vCPU to core ratio. So you would use this data point, 8.71 there. So that's a great question. So in the storage per VM field, if you don't know the storage per VM, you can actually click on don't know how much storage is required per VM, and then you can enter in the total storage required there. So in this scenario, we're looking at 150 terabytes usable. So if you just populate this with 150, based on the total number of VMs, it'll actually calculate what the per VM capacity is. So I'm just going to take some time to fill this information out for myself. And then a couple things that I want to point out here. So failure to tolerate methods. So we can deploy RAID 1, which is a full copy. There's a tax in terms of capacity of 50% using RAID 1, or we can use RAID 5, RAID 6 erasure coding. If you're going to leverage erasure coding from a failure to tolerate method standpoint, you have to have enough nodes to support that RAID type. So if we're talking 3-node cluster, for example, you'd only have enough nodes to support RAID 1. And the correct license. And then from a RAID 5 standpoint, minimum of 4 nodes. RAID 6 requires a minimum of 6. But again, you would want to have that extra node there so that you could recover in the event of a failure and maintain the level of protection that you want for the environment. And then here is where you can select the I/O profile, right? So this access pattern is more random over sequential. 4K block size is typically what we see, and the I/O ratio is 70-30. There are advanced settings that I want to show you guys. So So first is the cluster settings before we get to advanced. In the cluster settings, you can actually modify some of the server default settings. So if you know that, hey, we're looking at a server that has, a 2.6 gig processor and it's going to have 16 cores, the sizing tool will actually use that default or the new server configuration. It'll actually use that in its calculations, and you could see a benefit to increasing those different components, right? So being able to support more VMs per node, potentially having a smaller cluster, or maybe you're retrofitting in an existing environment and you know that, hey, I actually have a 2.1 gigahertz processor, and I have a 10 core. The processors are 10 core. You can make those adjustments in the server configuration, and be more accurate in your be more accurate when you actually spit out what the config is going to look like. Sure.
So I have played around with these numbers a little bit, so increased especially the memory.
Mm-hmm.
However, in the configuration that it spit out afterwards, I still had like the basic processor, the nodes with 120 gigabytes instead of 700 something I put in.
So if
Reason for that, or?
so it should so if you were to say change the max memory from 384 to 512, it should use that. But if it's in a situation where you say you're talking about a 50 VM cluster, and you can adequately support those VMs on, say, 4 nodes, it's not necessarily going to give you, a node with 512 gigs of RAM when you can support that same number of VMs with less memory. So that could be the instance that you're running into. But typically, if you modify these settings, so increasing the capacity drive to, and I often do this when I'm sizing for a vSAN cluster, is changing out these 1.9 drives, 1.9 terabyte drives to the 3.8s. It uses that in the recommendation calculation. The BOM that it spits out, which I'll show you guys here in a sec. And so we go to the recommendation, and you see based on the data that we provided, the data that we inputted, the recommendation here for me is 6 ESX hosts supporting approximately 68 VMs per server. Then it breaks down the raw storage calculation, and then based on the RAID type that we're going to be leveraging, which is in this instance RAID 5, what the usable storage is actually coming out to. And this is also in the input section there. What I didn't review is the deduping compression. So default is 2x. Typically I use 1.5 from a sizing perspective, but I skipped over that. So it's also calculating what your deduping compression savings are going to be in this output here. And then when you scroll down, you can actually see what does that look like from a server configuration standpoint. So 32 cores per node, and this is dual socket server, a minimum of 2 disk groups, which is a design best practice for vSAN. Breaks out the raw capacity, and also calls out the class of drive that you want to use for the caching tier, as well as the capacity tier. And then here's where you can select your ready node vendor. So in this instance, I'll go ahead and select Dell. And we were just going through this. So here we go. We got a Quanta server here at the bottom. That'll show you guys what this looks like. So you would see basically this is a certified ready node from Quanta with all of the specs based on the recommendations. This isn't always going to align perfectly with the output that you see here. But again, like I mentioned earlier, you can change some of these settings, right? So you can play around with the cores, the number of cores. You can increase the memory. You can get it more rightly aligned with what the tool is actually saying, because these ready nodes are just standard configs. They're preset configs, and so sometimes it's gonna try and get as close as it can. So just something to be aware of. That you may run into those instances where it's like, hey, the tool said, I needed a 4-node cluster, but it's giving me, a vSAN ready node BOM that includes, 6 nodes. You just change that, right? And so that's pretty much what I wanted to cover as far as the sizing tool goes. Any questions about the tool or any particular challenges that you guys have run into using the tool in the past? Sure. Question here. Yeah, thanks for that. That's actually something that I want to show you guys. So I talked about the Live Optics tool. Yep. So his question was, is there any plans to incorporate basically like an auto feed, auto export of Live Optics data or RV tools so that it feeds directly into the sizer? And I was going to show you guys, so yeah, that's actually coming. For RV tools, we can actually upload the RV tools data directly into vSAN sizer today. But for Live Optics, what's coming is when you create a Live Optics report, you'll have an option to export that to the vSAN sizer, and it'll automatically auto-populate all of those various fields that we just went through and manually filled out. It'll auto-populate that information, and then you can go from there to create your actual vSAN ready node BOM. And I was going to show you guys a quick little 1-minute video of what that looks like. So this is the Live Optics tool. Again, you've already created your report. You're going to go to the vSAN sizer beta. And it's actually going to automatically log you into the vSAN sizer tool. So you go down there and select the workload type. In this instance, we're sizing for a database. You see that information is automatically fed into the sizing tool. So there's one manual step right now, but where it's going to answer your question is it'll just auto feed that information directly into the tool. Any other questions? Mm-hmm. Right. Yeah. So, and Ken, you may want to remark on this as well, but yeah. So the VDI is tricky, right? The vSAN sizer, I think, provides some good baseline, some kind of directional tips on where to go from a sizing standpoint. But there's other things that you want to consider outside of like full clones, link clones, and number of VMs. So if you had those other data points, what I was saying, if you don't have a familiarity with VDI and sizing for VDI, in my experience, it's best to reach out to work with a specialist, and you can come up with I would say like a mock config for that particular environment using the sizer. But I would run that by a specialist just to make sure there isn't anything that you're missing from a configuration standpoint that could potentially be a problem down the line. And I don't know, Ken, if you have any other thoughts on that.
Yeah, we have guidance that we published, reference architecture on storagehub.vmware.com. That'll give you an idea of some commonalities to look for when you're sizing for Verizon and Citrix environments. Some of the things are, they're going to stay constant. You're going to need so much disk, you're going to be needing so much CPU, so much VRAM, right? But what I think Anton is referencing is just the nuance around the VDI configuration itself. You know, whether or not you've got the link forms in place. If you're looking at something like app volumes to instantly mount applications, you just want to bring that other domain expert into the equation to round out that sizing exercise. So we can get together after the session too and swap emails and provide further information there. Thank you. You bet.
Thanks, Ken. Any other questions? Sure.
How about multi-site deployment, stretch cluster, something like that?
Yeah, so stretch cluster is actually an option in the sizing tool. But from a stretch cluster perspective, it's really simple, right? We support, so for those of you that don't know, we support stretch cluster, metro cluster for vSAN, where you have two physical locations, right? And you're essentially extending the data store. So you have nodes, you know, say 10 nodes on one side and 10 nodes on the other side, and you're extending the data store across that physical location. There's some requirements in terms of latency between those sites, so sub 5 millisecond latency and a 10 gig pipe between the two sites, right? But from a sizing perspective, really what you want to account for is, do I have enough capacity to fail over in the event that, you know, I had a, you know, catastrophic, you know, event take out one of my data centers? Do I have enough capacity? Do I have 50, you know, the 100% of data that's going to be restarted on the secondary site? Do I have enough size in the vSAN cluster to support those VMs that are going to restart? So, so we have that drop-down option. You'll see at the end of the tool when you get to the recommendation part of the vSAN sizer, you can actually see for stretch clusters what the config will look like. But the math is pretty simple, because you're really just calculating times 2 and then making sure you have enough capacity on both sides to house those VMs in the event of a failure.
So that seems just to double the number of nodes, as far as I see here, yeah?
Right, right. Well, and like I said, the other consideration though is that you don't want to just double. You don't just want to say, hey, I got 50 terabytes here. I need 50 terabytes here. You need 100 terabytes, right, at both sites. Because if you were to have a outage, that 50 terabytes worth of VMs are going to be restarted in the secondary site, and you need enough capacity in that cluster to handle that workload. Does that make sense?
This just doubled. So I have the same amount of space on both sides. And then it changed from an advanced to an enterprise license. I think that's the only difference. As CEO, when I switched to size for two sides. That's the option you meant, right?
Yes, but yeah, maybe I did a poor job of explaining it, but you just have to understand that from a capacity standpoint, that you have enough space on that secondary site, so that if you were to have an outage, you have enough space that those VMs can restart without any issues, that you're not capacity constrained. So you wouldn't just say, hey, I can completely fill up the 50 terabytes that I have in site A, and if I were to have an outage, right, think that you'd be able to support that 50 terabytes worth of VMs in your secondary cluster, which only has 50 terabytes. You understand? You would need 100 terabytes worth of capacity on that site. So you just have to understand that I can't completely fill up this cluster because I need enough space in the event of a failure on the secondary site.
Mirrored side, how it is in size or
So, I'm sorry, go ahead. What was the question?
completely mirrored side when I go to this two-side scenario in the sizer?
No, it's a mirrored site. What I'm trying to articulate is that you just have to have enough capacity to sustain a failure so that
But if it is mirrored, I have all the data on the other side already, so there is no additional space I really need.
Part of the consideration too is you've got, and it's a little off topic from a sizing perspective, but with a stretch cluster, you've got a global failure to tolerate, to which, to your point, provides a mirror on both sides of that VM storage objects. But you also have a secondary level of failure to tolerate within each site. So if you lose one site, you've got additional protection within your surviving site. So you have to consider your requirements around that. What would you like that secondary level of failure to tolerate to be? Let's say it's RAID 1. Then you're going to have additional copies of the data within each site. And that's what gets highlighted in the sizer.
But that's what I initially put in the sizer, right? Before I switch between one side and two sides, yeah?
Correct.
Yeah, okay.
Yep.
another question back here. So from a sizer perspective, I don't think that's explicitly called out in the sizer. But what I would recommend using is again storage hub. It outlays all of the networking considerations and networking requirements for stretch cluster. Really, what it comes down to is making sure you have, again, a 10 gig link between those two sites, and sub 5 millisecond latency. But if you want more detail above and beyond that, I would recommend using that storage hub site, because there's tons of great information around exactly how that calculation is derived.
If you know your change rate, there are some formulas in the documentation that can help you with that, sizing the consumption of the bandwidth across that 10 gig link. But the requirement is the 10 gig link and the sub 5 milliseconds of latency. If you want to know the math to kind of calculate, you would need to know your change rate and use the formula that's in the documentation on the storage website.
Want to just write the storage hub?
Yeah, definitely.
Folks have it or ask them back.
Yeah, I'll write that up. Any other questions? Cool. Well, one question. Mm-hmm. So no, there's no way to specifically force it to say, hey, I want to use like 12 gig SAS SSD or 6 gig SAS over SATA. But that's one of those things that you can actually modify when you work with the vendor to actually build out a quote. Is making sure that whatever changes that you make, making sure that you check those against the HCL, so our VMware compatibility guide, making sure that it's a supported drive. But yeah, you can definitely say, instead of SATA, I want to go, again, 6 gig SAS or NVMe or what have you for the capacity tier. Sure. So the question was around. Hey, sometimes the config or the sizer spits out SATA as the drive to be used in the capacity tier, and can I force it to say, instead of using SATA drives here, I want it to spit out a SAS drive, and I was saying you can't specifically change the drive type, but that's something that you can in the sizing tool, but you can change it afterwards when you work with your OEM partner and say, hey, instead of going with the SATA drive here, I want to go with again SAS. Any other questions? Okay, no questions. So I'll go ahead and write the storage hub link up on the whiteboard here. If there's any questions afterwards, feel free to come up to myself or any of the other guys, experts in the back, and talk to them. But appreciate your time. And thank you.